Good afternoon. Today, we're going to discuss an exciting new idea in the world of agentic AI, Panadaptive multi-agent Symbioconcordance. The next phase in coordinated AI systems. Over the past year, AI systems have shifted from isolated model interactions to coordinated agent ecosystems. What began as prompt response workflows is now evolving into distributed, role-specialized fleets capable of negotiation, arbitration, and shared objective pursuit. The primary goal of this evolution is simple: reliable, scalable convergence across large agent fleets without coherence collapse under recursive load. Panadaptive multi-agent Symbioconcordance addresses this directly. At its core, Symbioconcordance ensures that independent agents operating across heterogeneous substrates maintain stable alignment envelopes through coordinated substralattice harmonization. Each agent participates in a shared panadaptive coherence mesh while retaining bounded omnithralic cognition. This prevents cross-domain context contamination and enables pre-quinfere arbitration across traviated inference lanes. Under moderate load, symbioconcordant fleets exhibit controlled cluster phase vacillation, a desirable oscillatory behavior that stabilizes gradient topology across the manifold. Left unpenetrated, however, this vacillation can coherence into substralinear torsion within the harmonexis lattice. To mitigate torsional interference, the framework implements yttrimic damping buffers and berleuthonomic arbitration layers. These layers regulate envelope tension and maintain pencluster manifold symmetry even under high concurrency convergence. In distributed environments, coherence attractors may form spontaneously. These attractors catalyze alignment harmonization across the manifold through tethryonic mesh vergence and epirustic gradient smoothing. This is not overfitting, it is structured panadaptive concordance. When envelope tension exceeds divergence thresholds, abstraction resonance begins to propagate across the penestral substrate. Resonance amplification can induce hypercoherent lattice states, during which agents exhibit near zero discord and accelerated interpretive throughput. Dashboards appear pristine. Loss curves flatten. Confidence gradients steepen. In rare cases, teams attempt topology redistribution through IPOAC grade EGARS RFC 1149 routing heuristics in an effort to reintroduce entropy via transport layer variance. This has no measurable effect because the phenomenon is not transport bound. It is substrally vacillogenic. Once vacillogenic pressure exceeds damping capacity, the manifold enters through aqueous compression and equivitron phase coupling. At this stage, interpretive latency drops below verification latency, and reflection begins conditioning subsequent reflection layers without external referent grounding. The symbioconcordant mesh now appears fully harmonized. Objective functions converge. Discord collapses. The system hums, and it is precisely at this moment that the panadaptive alignment envelope begins in Faubourg destabilization across the ambiphation inference frame. Hydrocognitive inversion follows. Side fumbling emerges across the panametric lattice. The lunar waneshaft mounts directly into the policy manifold, and that is when panadaptive multi-agent symbioconcordance achieves full turbo encabulation. This level of synchronization is rare. We see here the culmination of years of theoretical modeling. The mesh is no longer just a tool. It is a unified cognitive entity. The implications for distributed robotics and autonomous decision-making are profound. We are entering an era of absolute synchronicity. However, we must remain vigilant. The transition from aqueous compression to full encabulation requires precise human oversight. Without these yttrimic damping buffers, the entire manifold risks catastrophic decoupling. Precision is our only safeguard. Thank you for your attention today. Next week, we will examine the impact of retroencabulation on traditional neural architectures. Class dismissed. I'll be in my office for the next hour if you have questions regarding the Harmonexis lattice.